Hello everyone. In this video I will talk about LTE network architecture. I will say it with very simple and easy way. Okay, let's start. The LTE network architecture is divided into three main components: the UE, user equipment, EUTRAN, the evolved UMTS terrestrial radio access network, the evolved packet core EBC, and the evolved packet core communicates with packet data network in the outside world, such as the internet or the IP multimedia subsystem. The interface between the different parts of the system are denoted UU, S1, and SGI, as in this picture. Okay, the user equipment. The internal architecture of the user equipment for LTE is identical to the one used by UMTS and GSM, which is actually a mobile equipment, ME. The mobile equipment comprised of the following important modules: mobile termination, terminal equipment, UICC, Universal Integrated Circuit Card. Okay, a USIM stores user-specific data very similar to 3G SIM card. This keeps information about the user's phone number, home network identity, and security key. Okay, the EUTRAN. The architecture of EUTRAN has as this picture shown. The EUTRAN handles the radio communication between the mobile and the evolved packet core, and just has one component, the evolved base station called Enode B. Each Enode B is a base station that controls mobiles in one or more cells. The base station that's communicating with a mobile is known as its serving Enode B. LTE mobile communicates with just one base station and one cell at a time, and there are following two main functions supported by Enode B. The Enode B sends and receives radio transmission to all mobiles using the analog and the digital signal processing function of the LTE air interface. The Enode B controls the low-level operation of all its mobile by sending them signaling message such as handover commands. Okay, each Enode B connects with the EBC by means of the S1 interface. It can also be connected to nearby base station by the X2 interface, which is mainly used for signaling and packet forwarding during handover. The home Enode B is a base station that has been purchased by a user to provide femtocell coverage within the home. A home Enode B belongs to a closed subscriber group, CSG, and can only be accessed by mobiles with a USIM that also belongs to the closed subscriber group. Okay, now we will talk about the EBC, the evolved packet core. The core network. The architecture of evolved packet core has been illustrated as this picture as shown. There are few more components which have not been shown in the diagram to keep it simple. These components are like the earthquake, the EIR the equipment identity register, and the policy control and the charging rule function, BCRF. Okay, now we will talk about HSS, the home subscriber server. The HSS component has been carried forward from UMTS and GSM is a central database that contains information about all the network operators' subscribers. Now, the BDN, the Packet Data Network. B gateway, communicate with the outside world, as example Packet Data Networks BDN, using the SGI interface. Each packet data network is identified by an access point name, APN. The BDN gateway has the same role as the GPRS support node, GGSN, and serving GPRS support node, SGSN, with UMTS and GSM. Okay, now we will talk about serving gateway. SGW, serving gateway, acts as a router and forwards data between the base station and the BDN gateway. Now we will talk about MME. The mobility management entity controls the high-level operation of the mobile by means of signaling messages and home subscriber server, HSS. The PCRF, the policy control and the charging rules function, is a component which isn't shown in this picture, but it's responsible for policy control design making, as well as controlling the flow-based charging functionalities in the policy control function, which resides in the packet gateway. Okay, now we will discuss the interface between the serving and the BDN gateway. Is known as S5, S8. This has two slightly different implementation, namely S5. If the two devices are in the same network, okay, S5, and S8 if they are in different network. Okay, now we make a comparison between EUTRAN and the EBC. The EUTRAN functions as intercell RRM, RB control, connection mobility control, radio admission control, Enode B measurement configuration and provision, dynamic resource allocation scheduler. And the EBC, evolved packet core, MME, the MME, NAS security, idle state mobility handling, EBS peer control. The serving gateway, mobility anchoring. The B gateway, packet gateway, UEIB address allocation and packet filtering. Okay. A network run by one operator in one country is shown as PLMN, Public Land Mobile Network, PLMN. And when a subscribed user uses his operator PLMN, then it's said home PLMN. But roaming allows user to move outside their home network and using the resources from other operators' network. This other network is called visited PLMN. Okay, now we will discuss LTE roaming charging. The complexities of the new charging mechanism required to support 4G roaming are much more abundant than in 3G environment. Few words about both prepaid and postpaid charging for LTE roaming as given below. Prepaid charging and postpaid charging. I will discuss it as the next video. Okay, now we will discuss an LTE network area is divided. The LTE network area. The LTE network area is divided into 3 different types of geographical area as below. The MME pool areas. This is an area through which the mobile can move with it a change of serving MME. Every MME pool area is controlled by one or more MMEs on the network. The serving gateway service area. This is an area served by one or more serving gateway through which the mobile can move without a change of serving gateway. The tracking areas, the MME pools area and the serving gateway service area are both made from smaller non-overlapping units known as tracking areas. They are similar to the location and routing areas from UMTS and GSM will be used to track the location of the mobile that are on standby mode. Okay. Now we reach at the end of the video. Okay, thank you.